rod it is. What it is made up of, so what I do is like I'll take a thread, uh, non-conducting cotton thread. I'll take a cotton thread. I'll dip this cotton thread in a charged liquid, and the liquid will get deposited along the length of the thread, and that will become a line charge. Getting how to produce. So we have point charges we have come across. So now what happened? The charge bodies. I'm starting with this one. So what I do is this is a cotton thread. Cotton thread is a non-conduct cotton thread or plastic. Don't take conducting one. Cotton thread or plastic wire. It will be thin. It should be thin. I will dip this in some liquid, charger liquid, positively charged liquid. So what will happen to the liquid? The liquid will deposit on the thread, and that will become a line charge. So how to produce a line charge? There's a one idea is what I'm proposing. Getting know. So in books we don't have much information that is just started. So students often get confused. Sir, what is the method? This is the easiest one. Everyone knows, like if you just dip a cotton thread in a water, the water will get stuck to the thread. Similarly, the charged layer, the charged liquid or pen will get stuck to the cotton thread or the plastic wire. So in this way, I'll get the line charge. After this, how the charge distribution will be uniform. Charge will be distributed uniformly. Will be distributed the charge will be distributed uniformly throughout its length. So then I'm able to define the lambda. So what is lambda? Total charge by length of the thread. What is Q? Q will become total charge. This lambda is called as linear charge density. What is the lambda? Lambda is called as a linear charge density. Linear mass density, where you come across, I think several chapters like center of mass, moment of inertia, and gravitation. Here, instead of linear mass density, linear charge density. What will be unit for this? Coulomb per meter. Have this much of idea. Such a line charge is what I have considered of length L. Linear charge density of this is lambda. It's a positively charged here. I want electric field strength at point P, at a distance A from one end. So what will be the field at this particular point? Do we have any formula for the line charge? No, because what we know is only electric field due to a point charge. But this is not a point charge. It's a charged body. It's a charged body. So what is the method? So I'll do one thing. I will take a small element of length dx. This element will have a charge dq. Then let it be at a distance x. Here I'll find out the field at this point P due to that only point charge. This is one approach what we'll have. Whatever the type of charge body, you have to assume an elemental structure. For line charge, what is the elemental structure? For a line charge, the elemental structure will be a small elemental length. Then what is this dq? Dq should be equal to lambda into dx. Charge of that elemental one. Now from the electrostatics, what is dE is equal to? dE should be equal to k dq by x square. There's a there's an electrostatic field at point P due to this elemental charge. The first time, let me write some. What is this one? Field at point P. Best thing, shall I suggest you after today's class, go back to gravitation and so instead of their elemental mass, you have a charge. I think at a stretch within today only you can finish off all EBA due to all that one. Need not to wait for teacher. Okay, now let's get into the mathematical part. Okay, this will become further dq will be lambda into dx. So this will become k lambda x to power of minus 2 dx. So this will be now what should be the limit? Where do this? This is what x equal to 0. What is this length? X equal to a. What about this length? X equal to a plus l. Try to see the limit and defining this x equals 0. Where the charge is present? Charge is present in the region x equal to a to x equal to a plus l. So the limit will be a to a plus l equal to k lambda x to power of minus 2 plus 1 minus 2 plus 1 a to a plus l minus 1 by x a to a plus l. So then minus of minus, this will be plus. So the final answer will be equal to k lambda L A into A plus L. What is K? K is 1 by 4 pi epsilon naught. In yesterday's class, we had a discussion. No? So the value of K is K lambda L A into A plus L. So this will be the field due to, electric field due to this finite line charge. How it will be directed? Okay, let's, this one. So the direction of this field will be here in this direction. Like that at every point, as you vary A, as you move away, the field strength should decrease. Getting the idea? This one? Any doubts you can clarify, because there's a very fundamental, because almost 10-15 numericals revolves around this idea. If you have any doubt, you can just clarify. Okay, no problem. Okay, I'll scroll down. Anything you can put in chat box. Any such doubts you have, you can put in chat box also. Now small idea-based problems can be asked for you. Suppose if this is the rod, charger rod it is. Rod is natively charged, the field will be towards, if the rod is natively charged, the field will be towards, because for native charge, how the field should be. Okay, I'll draw that. If it is a native charge, the field will be directed towards the charged body. Okay, the field will be towards that one. If the positive charge body, the field will be directed away from the body. If the natively charged rod, the field will be directed towards the charged body. So the basic idea: positive charge, negative charge, the E bar due to positive and negative charge. So if it is like this, there's a charged rod. Exactly the midpoint I'm asking. Uniformly charged rod it is. Exactly the midpoint, what is the electric field strength? Anybody wants to answer? Please do think. Exactly the midpoint of the rod, what should be the field strength?
0, sir.
Should be
0,
0.
sir.
Yeah, it should be 0. Fine, good. Yeah, it should be 0. Some limits, some conditions will come. Just like a, you can say like a some sort of to have awareness, because like a what you can ask me a question is like, sir, even at the midpoint there should be some charge. Okay, that limitation conditions will come. Just qualitatively we are just analyzing it. The field strength at the midpoint of the rod will be 0. Okay, I agree this. And now at the 1/4 of the length of the rod, I think such surprise questions can come for you in exams. You have to be alert. At 1/4 of the length. Lambda be the linear charge density. At the 1/4 of the length of the rod, what be the field strength? I think due to this, like a quarter length, and next due to this quarter length, will cancel out no the field at this point P. What will be field? Who will contribute at point P? This off. This off will contribute the field at point P. Able to analyze the field produced by. So what is the reason? Suppose say like I say I have a two charges. Now what is the field strength at the midpoint? Should be 0. Got it? Exactly at the midpoint, what will be the field strength? Will be 0 because due to this positive charge, E bar will be towards right. Due to this positive charge, E bar will be towards left. The resultant field at point P will be 0. Similarly, the E bar due to this quarter and the E bar due to this quarter length will be equal and opposite here. Who will contribute the field at point P will be the remaining off. So then point P will be at what distance? This is equivalent to rod of length L by 2. Then what is the distance? Will be L by 4. So what changes will make it here? In place of L, I should write L by 4. In place of A, I should write L by 4. Instead of A, capital L, L by 2. Instead of A, L by 4. Simplify this, you'll get the required answer. Anybody? K lambda. Anybody value? What shall I write?
8k lambda by L, sir.
8k lambda by L. Nothing will come 3, so nothing will be
Sir,
there.
8k lambda by 3L.
8k lambda by 3L, sir.
3L, yeah. Yeah, this one. How it will be directed? Direction?
Towards right, sir.
Towards right. Okay, this one. These are the objective questions, where as a teacher, I really, because in the books we have till year. What are the numericals I can test you in exam? The same formula. If you know, if you remember this formula, okay. If you are unable to remember this formula, you should derive. You should work out. So I suggest you better to memorize this, make it a memory. In exam, you can directly start with this one. You need not to derive, then get into question. Directly, if you know this formula, you can attack